Hey everybody, it's Mr. Carr again. We're going to be talking about 1C today, and we're going to be covering what's called the distributive property and combining like terms. So a little bit of review igniters. Again, I'm going to pause the video. I want you to try these out as best you can on your own. Give you plenty of warning that I'm going to be pausing that video right about now. Oh, okay. So here's my answers. A little reminder, round to the nearest hundredth. My decimal numbers, it goes tenths, hundredths, thousands. So if I look at the hundredths, I'm just going to look at the number next to it is a 1. So that just rounds down to 6.58. Okay. Here's my fractions. I'm going to add them together. They add up to 44/15. Multiplying these are going to come out to a pretty big number because there's no cancellations, 77/200. Okay. So you've worked with all these different skills. We're now going to be talking about our distributive property, which also leads to combining like terms and what that means. So start with, and then evaluating expressions, which you've already done. So I don't know why that's on there. Yeah, that's an old one. I don't know why. That's weird. Okay. Distributive property. Okay. So distributive property, I like to show this as a quick little way of kind of demonstrating it. If I have this expression, I got multiplication in front, the distributive property states that this right here is the same as taking A times each of those other values. So I can instead of doing it as B plus C inside first, I can actually do A times B and then A times C. All right. I like to show this as a quick little aside. I think I could do it right. Yeah, let's add another page in here. No. Perfect. Okay. So for distributed property, I like to demonstrate it like this idea. So let's say I'm taking 2 times 3 plus 4. Okay. Come on. Yeah, I don't know why it's doing that, but it's back. Okay. So normally order of operations says let's take 7 or 3 plus 4 is 7. So this is going to turn into 2 times 7. Then I'm going to take 2 times 7 is 14. But if I do distributive property, then that means that this should still be the same. If I take 2 times 3 and 2 times 4, that should come out the same way. 2 times 3 is going to give me 6. 2 times 4 is 8. Look at that. I get 18. Awesome. It's nice when it works out that way. Okay. So that's what we're looking at here. Distributive property does work for a real life number. So now we're going to focus in on how we apply that with our algebra expressions. If we have these unknown expressions like this, well, I still apply that distributive property. 3 is going to be multiplying to both x and 5. So that is 3x plus 3 times 5 is 15. Here for number 2, technically speaking, that's a -1 in front. So I can still distribute the -1. So it kind of looks like this: -1 times 9y plus a -1 times 27. So -9y minus 27. There's shortcuts there, but I just want you to see I'm actually distributing a -1. Here I'm distributing -10. So I've got -10 being multiplied by the 3 and being multiplied here. This is going to be a key one. I'm going to take -10 times 3 and a -10 times a -2x. So -10 times 3 is -30. Here's the thing that traps people. Notice that I'm taking a negative number here and a negative number here multiplied together. So you got to be very careful there because that's going to turn to a positive 20x now. I don't have to show it as like the value in front is being distributed. I could actually do it behind. Here's my parentheses expression. And then here's 11 kind of attached in the back. I'm still going to distribute that. So it's going to still be 11 times 10 plus 11 times 7b. So that's going to give me 110, and that's going to give me 77b. Okay. Combining like terms. So we're going to simplify these following expressions. When we simplify these, we can only put like terms together. And what that means is the variables and exponents must match. So for example, here I got 5k and 9k. Both of those are k's. They're both to the first power. I can put them together. When we combine our like terms, all we got to do is the operation that's in front. So for example, 5 minus 9 is a -4. So this just turns into -4k. The variable stays there. We don't lose that. It has to be a part of it. Now look at this one. I got z, t, and z again. So my like terms are actually these two. So that's one thing I like to do. If I get a complicated expression, I like to go through and maybe like circle all the one variable, put a box around another variable, draw a line underneath another one. Okay, just do different symbols to help you kind of organize what's your like terms. I did something there. Okay, so 7z minus 2z is going to give me 5z. And then I'm still left with 3t at the end. For number 7, start off with distribution. Okay, I do have like terms here, but I got to get rid of these parentheses first, just like my order of operations. I've got parentheses. I don't want those there to like, because that's going to throw off my other stuff going on here. So I've got 9 times 2x is going to give me 18x. 9 times 4 is going to give me a -36. And then I have plus 7x and plus 5. And then this is what I was talking about before, where I might go through and all of my x's get underlines. Then I have just whole numbers here and a whole number here. So those are what I'm going to combine for my like terms. Again, it has to match both variables and exponents. So 18x and 7x, add those together, I get 25x. -36 and a +5 is going to be a -31. All right. And that is it. Another quick one today. So that's it for Unit 1. We're going to go ahead and do our final test for this on Unit 1 and go from there. Okay. So that's it, everybody. Take care.